Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1, and today's chapter is partial derivatives, and today's topic is second and higher order partial derivatives. Okay, so for that, what is basic requirement? Basic requirement is formula of derivatives. Okay, and the rule of derivative, nothing else. But how we will find the second order, second and higher order? Let's have a look on the basic concept of second and higher order partial derivatives. Partial derivative of higher order are obtained by partial differentiation of first order partial derivatives. That means second order or higher order derivative are obtained from the first order partial derivative, and we know the first order partial derivative, that means if u is a function of x and y, that means u is dependent variable and xy are independent variable, then first order partial derivative of u with respect to x is given by this, and first order partial derivative of u with respect to y is given by this. And what is the notation for with respect to x is ux, and notation for with respect to y is ui. Okay, so by differentiating this first order partial derivative again and again, we can find second and higher order partial derivatives. So let's have a look. If u is equal to f of x comma y be a function of x and y, then first order partial derivative del u by del x and del u by del y are also function of x and y, that we know. After differentiate given function, answer will be of the form of x and y only. And we may further differentiate this del u by del x and del u by del y with respect to x and y. Okay, so they are usually denoted by this: first order partial derivative of u with respect to x partially, that means del u by del x as I told, and in notation we write ux. Same way, first order partial derivative of u with respect to y is given by del u by del y, and which is written as in notation uy. Now if we differentiate this del u by del x again with respect to x, so del into del square u as it is, and del x into del x will be del x square. So del square u by del x square, and in symbol, in notation, we'll write down uxx, that means ux and x. Okay, again with respect to x. Now same way, if we differentiate this del u by del x with respect to del u by del y with respect to x, then del into del square u upon del x into del y. Okay, so this is wrong. We will write del x into del y like this, and we know first order partial derivative del u by del y is given by del y, sorry, uy, and we differentiate this term with respect to x, so x multiply here, okay, with y. So this is the notation for differentiation of u with respect to y first, then x second. Okay, now again if we differentiate this term, this is the differentiation of this term with respect to x and this term with respect to y, that means del by del y of del u by del x. So this will be del square u by, here we have del y into del x, del y into del x, and this notation is given by ux we have already, that means this ux we have, and we are differentiating with respect to y, so multiply only y. Okay, same way, if we differentiate this term with respect to y, we have del by del y of del u by del y, that means del square u by del y into del y, that means del y square. So we have uy, so this uy, and again we are differentiating with respect to y, so multiply only y. So these are the notation. how we can differentiate, and what is the notation for second order partial derivative, and higher order also we can write same way. Okay, so let's have a look on the example how we will apply this concept to the example. We will see by the example number 1. First example, find all second order partial derivatives. So first, before starting this example, let me introduce you the all second order partial derivative, then we will start this example. So if we have any function f of x comma y, which is like given in the question, so first we will find the first order derivative. That means del f by del x with respect to x and del f by del y with respect to y. These are the first order partial derivative. So then after, by again differentiating with respect to x and y of this term, we have this one. So okay, I'm writing here, we have del by del x of del f by del x. That means del square f by del x square, and del by del y of del f by del x. Same term, del f by del x with respect to x and with respect to y. So we have del square f by del y into del x. Same way we can differentiate this del f by del y with respect to x as well as with respect to y. That means del by del x of del f by del y, and we can write this term as del square f by del x into del y. Similar way with respect to y, what differentiation of what? So del f by del y. So this term, okay, so this term also differentiate with respect to x and with respect to y. So we can write del square f by del y into del y, that means del y square. So these four derivatives are second order derivative. So whenever all second order partial derivative asked, you have to find all these four derivatives, and to find all these four derivatives you have to first find these two derivatives. Okay, and what are the notation? So let's write down the notation also so you can understand better. So notation of del f by del x is what? We know that f x. Now if I am differentiating this term fx with respect to x, so it is written as fxx, and same way this is fx already, and I am differentiating this term with respect to y this time, so just multiply y only. Understood? So that means fxy, that means differentiate f first with respect to x, then with respect to y. Okay, that means in this form you have to go in this direction, x and y, in this form x and y. Okay, similar way if we differentiate this f with respect to y, so we will write down f y, and this fy is differentiable with respect to x, so f yx. So in this notation, first we differentiate with respect to y, then x, and same way here y and x. So in this form you have to start from right to left, and in this form we have to start from left to right. Okay, and 2 times with respect to y, that means f y. Don't write y square, keep in your mind. So these are the all second order partial derivative, and to find second order partial derivative you have to find first order partial derivative compulsory. Okay, so I'm just removing this, just you can take a look all these four second order partial derivatives. Okay, now we are starting with the example. Let's start with the example. So first we will write down the solution. Start with the given function f of xy. So what is the function? X square y plus y square into sine x. So first we will find first order partial derivative, and then by using that first order we will find second order partial derivative. Okay, chalo, let's have a look. Hmm. So first we will find with respect to x, and already we have studied in part 1, part 2, part 3, in 3 lecture how to find first order partial derivative. So with respect to x, so y constant as it is and differentiation of x square is 2x. Same way y square constant as it is and differentiation of sin x will be cos x. Now we will differentiate this first order partial derivative with respect to x and with respect to y. So first we will differentiate with respect to x only. So differentiation of this del f by del x become del square f by del x square, and differentiation of this x is 1, so we have remaining 2y, so 2y. So and y square as it is, and differentiation of cos x is minus sin x, so minus sin x. Same way we differentiate this term with respect to y this time. So we are differentiating this with respect to y, so we apply del by del y on the left side. Okay, so notation will be del square f by del y into del x. You have to keep in your mind, okay, because we have del x and we are differentiating with respect to y, so del y will be multiplied on the left side. Okay, now differentiate this term with respect to y. So this time we want to differentiate with respect to y, so x is constant, so 2x constant, and differentiation of y is 1, so 2x. And this time cos x is constant and differentiation of y square is 2y. So in second order you have to make more concentration, okay, because this is del f by del x and we are differentiating with respect to x, at that time y constant, and when we differentiate this term, same term, this entire same term with respect to y, at that time x is constant. Okay, similar way now we will find differentiation of this given function y with given function f with respect to y. So differentiation of x square into y is x square, because we are differentiating with respect to y, so y is 1, and differentiation of y square is 2y, and sin x is constant because x is constant. Now we differentiate this del f by del y with respect to x as well as with respect to y. Okay, so what more two second order partial derivative will be obtained. So first we will find with this we will differentiate with respect to x. So if we differentiate with respect to x, so multiply del by del x, and that's why del x multiplied to the left hand side, and differentiation of this with respect to x is 2x, this 2y is constant, and differentiation of sin x is cos x. Same way differentiating with respect to y of this term, so differentiate with respect to y, here only x square is as x square is there, no y, so differentiation of x square is 0, and now 2 constant and sin x constant, because we are differentiating with respect to y, so differentiation of y is 1, so we have 2 into sin x. So these are the second order partial derivative 1, 2, 3 and 4. Okay, and you can see one more thing here, that first we differentiate with respect to x, then with respect to y, so we get del square f by del y del x. Make attention, pay attention here, del square f by del y del x, 2x plus 2y plus cos x. Same way when we differentiate with respect to y first then x, we will get del square f by del x del y. So in these two terms, in this and this, we just change the order. First differentiate with respect to x, then y, and here y, then x. But answer is always same. Okay, so you have to remember this thing, and this rule is known as, or theorem is known as, mixed derivative theorem. That means if u is equal to f of x comma y possess a continuous second order partial derivative, del square u by del x del y and del square u by del y del x, then the value of these two derivative always same. Okay, that means if you differentiate u first with respect to y then x, or first you differentiate with respect to x then y, answer will be always same. Okay, so this is called commutative property also. Okay, so let's understand this mixed derivative theorem rule by one example. We have w is equal to x sine y plus y sine x plus x into y. Then verify wxy is equal to w by x. First we will understand what is the meaning of wxy. So wxy, that means first we differentiate with respect to x and then with respect to y in this notation. That means del square w by, first we differentiate with respect to x, so del x, and then differentiate with respect to y, that del y. So in this form we have to apply new derivative on the left side, and in this form we have to apply new derivative on the right side. Okay, same way, what is the meaning of wyx? Chalo, think for 5 or 10 seconds and give me the answer. Del square w by, we will write first with respect to y and x, that means y, del y here and del x here, that means first with respect to y, so this is with respect to y, and then x on the left hand side. Okay, so let's start with the solution. First write down w. First we will differentiate with respect to x. Okay, because we want to find this term. So differentiation with respect to x partially, so y is treated as a constant, so sin y constant and differentiation of x is 1. Same way y constant, differentiation of sin x is cos x. Same way y constant, differentiation of x is 1. Now we differentiate this wx with respect to y, so we will get wxy. Okay, so now differentiation this term with respect to y, so differentiation of sin y is cos y, differentiation of y is 1, so cos x constant as it is, and differentiation of y is 1. Say equation number 1. Now we will find this wyx, that means differentiating with respect to y partially first. So wy of this term, so with respect to y, that means x constant, so x constant as it is, differentiation of sin y will be cos y. Same way sin x constant as it is, and differentiation of y is 1, and same way x constant as it is, and differentiation of y is 1. X into 1 is x, so no need to write down this one. Now we differentiate this wy with respect to x, so we have wyx, that means cos y constant, differentiation of x is 1, and with respect to x, differentiation of sin x is cos x, and differentiation of x is 1. So say equation number 2, and from equation number 1 and 2 it is observed that wxy is equal to wyx, hence mixed derivative theorem is true or verified. Okay.